Hi, welcome to the signal path. That's not supposed to be part of the video. Go away, Pooch. Hi, welcome to the signal path. Today we're going to do a Q&A session as I promised, and here I am sitting in my dining room recording this. That's because my lab is not up and running yet. And that's one of the very first things I wanted to talk to you about. I started the signal path in May of 2011, and since then the response from all the viewers has been exceptionally positive, and I'm really grateful for that. Now, I started the signal path purely out of my joy for teaching and to be able to distribute some of the knowledge that I know to so many people who are interested. And the signal path has been focused on the type of material that's either difficult to teach or difficult to learn. And that's really both a good and a bad thing, because the content is very advanced and the videos are really long. Some of my videos are almost 2 hours long. And that's because you cannot review a high-end instrument or teach a complex RF electronic concept, in 10 minutes. But if you look at the optimum length of a YouTube video that captures the most amount of attention is 10 minutes. If you look at some of the channels that have the highest number of subscribers, like the people who play video games or some silly videos here and there, they're always in chunks of 10 minutes. And there's a reason for that, because that's what the attention span is for capturing somebody's attention for, entertainment purposes. But these videos aren't essentially intended for that type of audience. It's intended for people like you who like to sit down and watch a long episode, like a lecture almost, and get the most out of it. But at the same time, it means that there are a lot fewer people who are interested in these videos. As a result of that, these advanced channels have much less followers. And I don't have any advertisement on my website. If you go to thesignalpath.com and disable your ad block, you see no advertisements. Any link that ever shows up on my site is a direct link. There is no tracker, so the manufacturers, for example, don't even know where that visitor came from. It's because it is never intended to make money. It wasn't the whole purpose of the signal path in the first place. And throughout the years, a lot of people have come and asked, we want to buy your content and then charge the viewers and so on. I said, absolutely not. This is not the reason why I'm doing this at all. And a lot of wonderful viewers have come and asked me to donate. And I've said, there's really no way for you guys to donate directly to me. Again, this is not why I was doing this. Now, since I've moved to a new place, and a lot of people are asking for, why don't you upgrade your camera, get a better microphone, do this and that. I would love to do all of those, but as you know, with every move, there's quite a bit of cost associated with it. So I decided to go ahead and put the signal path on Patreon. So whoever's interested would be able to go ahead and donate something to every episode, and everything that is donated to the signal path through the Patreon channel will go back to the signal path, back into the lab to be able to upgrade it, to build it, set it up, get better recording equipment, and hopefully do more videos. And as you know, RF equipment is not only expensive, but also RF components are pretty expensive. So it's an expensive thing to run. And believe me, it takes a very long time, and I'll get to some of the questions about that. To record a video, often I have spent my whole weekend creating an episode because it's just such a rewarding experience. And you don't know this, but all the episodes you've watched so far, I have produced about 66 hours of original content to this date. And they've all been recorded from my lab, and my lab used to be in my bedroom. So you guys always had the view towards the lab, but behind me, or behind the camera I should say, was my bed. So I used to sleep in the nice glowing LEDs of all my equipment in many years, and now I finally have my own place. And so I want to set it up in the basement in a nice place and have a proper lab so that I can move the camera around and be able to do great things. So this was really the main announcement about the signal path that I wanted to let you know about. And I hope that if you're interested, if you get benefit from these episodes, if you feel like the content is unique and that has value to you, if you like to contribute to it, I would be grateful. And I promise you that it would go back to the lab. And I'm only charging to the Patreon the long episodes. The short episodes do not get charged to Patreon because they're only 10 minutes. Again, I don't want to charge you for a 10-minute video. Only a real episode, which is usually quite much longer than that, will be charged to the Patreon. So anyway, so that's the announcement, and I'm working on getting my lab up and running. But as you know, moving is quite expensive. There's a million other things that I have to do before that I can start and do that. So anyway, I'm working on it. So there was a whole bunch of questions submitted to the episode, and there are a combination of technical, personal, advice, and so on. I'll do my best to answer you. I just copy and pasted them here. This is not rehearsed, so it's going to be kind of on top of my head, which I think is more interesting. Anyway, So the very first question is, other than inductors, does electromagnetic behavior play a role in solid-state devices? Well, absolutely, because on solid-state devices, we don't just make inductors, we make transformers and couplers and filters and a whole bunch of other components which rely on EM simulation. In fact, there is no modern RFIC that doesn't use electromagnetic simulation tool of some type in order to extract the behavior of all the components that have EM characteristics on the die itself. So this is a very, very common thing. In fact, we pay a lot of money for simulation tools that can do 2.5 or 3D simulation of all of our passive components that have EM behavior. So it's very, very common. Everybody does it. And this goes from 2 gigahertz to 200 gigahertz. It doesn't matter. It's a fundamental part of our RFIC design. And then the second question is, tell us a little bit about your career, your background. How did you learn about electronics? And just in general, what is it like to start in this field? Well, for me, I was playing with electronics since I was 5 or 6 years old, and I had a big influence from my uncles who were both engineers, and they really encouraged me. They gave me this kind of a gift of curiosity, which I think is one of the best things you can do for somebody, is to give them that gift, the gift of teaching them. In fact, I believe that aside from loving someone, teaching them is the most wonderful thing you can do for them. That's the whole point of this website in the first place. So when I started when I was 6 or 7, obviously I was just goofing around, trying to learn about how these little things work, get my hands on whatever electronic stuff that I could have. I took apart everything in our house, so my parents hated me for that. The stereo, the TV, nothing survived the screwdriver in my hand. But at the same time, I learned quite a bit about it, and with the right guidance, eventually became interested more and more, and actually did my degree in computer engineering and then switched to electrical engineering, and then my master's and my Ph.D. were all in electronics. And in terms of RF industry, there is really a broad range of type of jobs you can do as an RF engineer. Now, as an RFIC engineer, then there is, again, a whole bunch of different things you can do. My line of work is focused on ASIC design for high-speed communication, both for optical as well as wireless communication. And if you look at my publications and some of the work Bell Labs does, that's where I work, you can see some of that going on. So it's pretty interesting. I'll talk a little bit about it as we go along. And it's funny because when I was 9 years old or so, as a birthday present, I got my first digital multimeter, and this wasn't a fluke or anything like that. It was just some no-name, I think 3.5 digit, something that my mom had picked up. Again, this was back in Iran, back in the Middle East. It wasn't even in Canada. So I remember getting that multimeter, and I remember how happy I was. It's funny because that multimeter is basically something that wouldn't be even worth $1. Even back then, it wouldn't have been worth more than $20. And I got happier from that than having, let's say, a $100,000 spectrum analyzer in my lab or a $100,000 oscilloscope in my lab today. And it just really goes to show that it's about the experience, not so much about the value. So anyway, I wanted to share that with you. And then there's questions about what kind of books and so on that I would recommend. That really depends on your background and depends on what you're studying and what you want to do. For ASIC design, there's a whole bunch, and I'll try and put some links up. In fact, I was going to do a book review episode, which I'm working on. So that will be there, and I'll show you a couple of different books that are related to RFIC engineering and just in general about some of the things that you might find interesting, like The Art of Electronics, which is a very popular book among people who are interested in electronics online. That's a really good one if you want to get some practical examples and so on, but specifically for ASIC design, it's going to be a little bit different. So I'll make a recommendation of that. And the other question is, how do you manage your time, and how are you good at managing your time? I don't know why you think I'm good at managing my time. I'm not. I'm actually quite bad at it. The reason it seems like I'm good at it is because you only see the videos and so on, on a regular basis. But I'm not very good at managing my time. It's a skill that is continuously being worked on. And I think I'm going to have to do that until the end of my days. It's never going to master it. It's just how efficiently you work. And I think a lot of passion that goes into your job, that helps. Because if you're passionate about something, you dedicate time to it, even if your time is not well managed. But again, I do my best to do that. And life is always a balance. It's a balance between your friends and your love life and your health and your work and your hobbies. It's just always juggling all of these things together. So that's a skill, believe me. I'm not going to be able to give you any advice on that because I'm still learning that myself. And so I explained how I got into this field and my background already. And then there's somebody who was asking, can you talk about 40 gigahertz to 100 gigahertz? What components stop being viable? Will we ever see 100 gigahertz components on DigiKey? Well, why do we use 40 or 100 gigahertz or 200 gigahertz? Well, there is this thing that if you go higher in frequency, for wireless applications at least, there is more bandwidth available to you. If you're using Wi-Fi, which is sitting at 2.4 gigahertz, you're really restricted to very small channels of bandwidth that's allocated to you because everybody is using that band. So the ISM bands are crowded. And this is one of the reasons why this whole idea of 5G and going to higher frequencies and so on has come about, is because we have saturated the spectrum. There's just no more room. So you have to go to higher frequencies. And at higher frequencies, you have a higher amount of bandwidth available to you because the available bandwidth is a function of the carrier frequency itself. So there's always a percentage of the carrier frequency. And of course, the government has to approve that. The FCC has to approve that. And once everything goes through, then they give you a band and then you buy the band, you license your product and you have to stay in that band and so on. And that's why going to higher frequencies is one of the things they do in wireless communication, simply because they can send more data. And then the question is, will we ever see 100 gigahertz components on DigiKey? Well, yeah, you already do. If you look for 60 gigahertz radios, WiGig standard, you can buy 60 gig components and radios from DigiKey, I believe. I think I've seen them. That's 60 gigahertz. And these are now commercial products, so you can go and pick them up. To measure them and test them and so on is obviously more expensive, but those cost of those things will slowly drop as well as they become standard, as the new 5G wireless communication standards catch on. Testing will become cheaper because more and more competition will be in that space and more products will be made, more equipment will be made, and the price will go down. That's normal. So I don't see why not. This is just a matter of application. If there is an application for it that has large volume, you will be able to find it. And then there's another question here about signal modulation and sending signals over the air and then down converting them. So the question is, it's a long paragraph, but the gist of it is, if you're sending something at 2.4 gigahertz and then you down convert it, how come information isn't lost? And I think the reason that question is being asked here, there's a bit of a misunderstanding in the question itself. And I think the reason the misunderstanding is there is because the person who's asking probably hasn't completely figured out the difference between occupied bandwidth, carrier frequency, modulation type, modulation index, filtering of the pulses, pulse shaping, and these are all different concepts. So let me explain in a simple way. So information is embedded in signal to noise ratio, right? That's the most fundamental law of communication. That's Shannon's famous equation that talks about channel capacity. What is the most amount of information you can send in a medium that's noisy? And that's just signal to noise ratio. So if you have infinite signal to noise ratio, meaning there is absolutely no noise, you can pack an infinite amount of information in a tiny, tiny amount of bandwidth because there's no noise. So you can always amplify it back up. You'll have no problem. But of course, that's not reality. So in reality, you have a certain amount of bandwidth and a certain signal to noise ratio which you cram information in. So now let's say that I give you 10 megahertz of bandwidth. So I say in this 10 megahertz, cram as much information as you can depending on your SNR, and I want to send that away. So if I have 10 megahertz, I can't send that wirelessly because DC to 10 megahertz isn't going to propagate through the air very well. So we take that chunk of frequency, we move it to 2.4 gigahertz, for example. Now you have a 10 megahertz bandwidth sitting at a carrier of 2.4 gigahertz. And then we send that away. So the 2.4 gigahertz with 10 megahertz around it, that 10 meg is a small part of 2.4 gig. So it will propagate fairly uniformly throughout the air. And then when you receive it, you bring it back down from 2.4 gig and then you look at it. So it's not that the information is lost. It's just that the carrier moves it up and down in frequency to enable this transmission in a wireless medium. And then modulation type, pulse shaping, all the other parameters, bit rate, baud rate, they all relate on how you encode the information in that bandwidth, and what your SNR capability will determine what kind of modulation format you can use and all the other stuff. So go and look up these particular terms and then it will become clear why it is. Otherwise, it's not actually that complicated. Then there is one question which I honestly, I have no idea what it means. It says, have you really been far even as decided to use even Go 1 to look more like I have no idea what that means. So I'm going to answer yes. And that's that. And then it says, do you have, so there's a question about LDMOS. And then the question is, LDMOS has a lot of capacitance on it. And does that mean that when you make an amplifier out of it, it's going to be very narrowband? And the answer is yes, that's inherently the case. If you have a load that you need to match to, let's say 50 ohms in this case, and if you're very far away from 50 ohms and you look at the Smith chart and you have to travel a long distance to get from where you are to 50 ohms, the further you have to travel, more complex matching network requirements, the narrower the bandwidth of the matching network is going to be. That's just the way it is. That's why making really high power, broadband power amplifiers is so difficult, because big PAs have a lot of parasitics. The impedances are very low, and to translate that to 50 ohms can be quite difficult. So you're absolutely right. That indeed is a consequence of having a large capacitance. And then the question is, do you think simplified Arduino platform is generally a good thing or a bad thing for engineers? I've talked a little bit about this before. So Arduino as a whole, I think, is a good thing. It has enabled and it has encouraged a lot of people to play around with things that they would have never touched before, because it has such a rich community of resources. But this is a bit of a bad thing at the same time, because people who use it without understanding what it does and how it works can lose touch with how these components actually do what they're supposed to do. So you use something without understanding it. And I think that's fundamentally against engineering, because if you use something, you should at least have a fairly good idea of how it works. And not only that, if you were to build a board and put a microcontroller on it and put a crystal on it, put all the stuff on it, and you've never done it before and it's super simple, you're still going to make 100 mistakes and it's going to not work for 100 different reasons. So it's fine to use it as long as it doesn't detract you from learning how it works. So if you are really interested in it, then you will learn how it works and it wouldn't matter. But overall, I think what it has enabled is definitely been worthwhile, and I think it's a great thing. So just dig in, figure out how it works, make some mistakes, break some components, burn your fingers when you've misconnected something, and that is definitely worth it as well. And let me see, where was I? So oh yeah, so the question is, how do you advance in workplace? So I can give you advice on that, but it's always easy to give advice. It's always much harder to follow it. And it depends on where you are. So where you are in your workplace is a function of politics as well as your expertise. You can be a really good engineer and just be among people that you don't get along with, and it's going to be difficult for you to advance. It shouldn't be like that, because ideally, your position at work should be based on your performance and your knowledge and your commitment to your work, and not a function of petty disputes between coworkers. And I've been lucky I'm not in any of those situations. So it's hard for me to sympathize or trivialize this problem. It can be quite bad. But I can tell you one thing and what I expect from the people in my group. What I expect is a commitment to your work beyond your immediate task. And by that I mean, let's say if I ask you to go and simulate an amplifier for me. So it's like, there's this amplifier design, we know it kind of works, can you simulate it and bring me the result? And if you go and bring that back and you give me, let's say, a piece of paper or send me an email and says, yeah, I simulated this thing and the gain of the amplifier was minus 120 dB. Minus 120, and you just send that to me and that's the end of that. I'm not going to be very happy with that, because I would expect that as soon as you saw that result, that you would dig in and find out why it was minus 120, because a minus 120 dB is not an amplifier, it's basically something is horribly wrong. So that idea of digging in and really understanding what you're doing and having passion and commitment to the end result, not just the first thing you're supposed to do, is really important. Because every time you go to somebody that you work for, or even your colleague, you don't even have to be working for them. You go to them and give them something that's wrong, that you haven't thought about. There is a little piece of respect and a little piece of reliance that you lose, so they can't count on you anymore. So then the next thing you say has to be treated with some doubt, and you don't want that, especially in a technical environment and especially in a research environment, which is where I'm involved in. So my advice would be that commitment to really dig in and figure it out. And if you're unhappy and you don't want to do that in your work, or you don't want to do because of other reasons, then I sympathize. It's very difficult and you have to find a way around it. But be committed and be curious and show that you care about what you're doing. And that, I think, on average, will get you far. So then the other question is how to learn RF and so on. I talked a little bit about that, and there are so many lectures about RF, and there are so many good lectures from great professors from around the world that talk about the theory of RF. The only problem is that learning only about the theory can be a bit dry. You get bored, and that's why it's so cool to build these things in the lab, and that's why if you look at my videos, the format, there's a general format to them that I talk about the idea, the theory, the principles that's going behind it, and then we build it, and then we talk about how to measure it. Because if you don't know how to measure it, then you also are missing a huge part of electronics. So this full breadth of information from theory to practice to measurement to all of that is critical, and that's why I think a lot of people enjoy the signal path, and that's why I enjoy doing it, because to cover that whole range. So make sure you don't miss any of that. Don't underestimate the importance of theory. Don't underestimate the importance of being able to build it and have a hands-on experience. They all play their own role. And then somebody else asks, should I build every component, or is it okay to just use a component off the shelf? If my design has a PLL, should I really try and build a PLL, or should I just take one off the shelf? It goes back to the same Arduino discussion we had. You can use a component off the shelf. I mean, that's the whole way of building more complex systems. Just make sure you understand it, because if you understand how a PLL works and what its architecture is, what its principle of operation is, then you know what its weaknesses and strengths are. And once you know that, then it will help you incorporate it into your design so much better. And then if something goes wrong, you can debug it much faster. Or you know, should I use this type of PLL, or should I use that type of PLL? What's the difference between them? When would I use which one? In order to know the answer to that, you need to understand how PLLs work. So it's a little bit of both. You have to understand it before you can use it. This is something that I've always believed in. Every little thing, I think. Even you go and use your refrigerator, you should know exactly how that refrigerator works. Somebody invented that. Some engineer figured out how to build it, and it's a wonderful machine that's in everybody's home. You need to know exactly how it works, and this kind of how I think is being a good engineer is all about. So then someone else asks, estimate your success rate on repairing equipment. Do you sometimes attempt to repair and then fail, not show it? Well, I've been in a way good with that, because I have shown everything I've attempted to repair, and I don't try and record something, and if it doesn't work, I don't post it. Mostly because I just don't have the time to cherry pick something once I record it. If something is being recorded, it's gonna go out, because otherwise I won't have enough time. So there has been an occasion here and there where I haven't been able to fix something, and it happens to everybody. And there was one laser I was trying to fix, and during the move I had to throw it away because I didn't have enough room to bring it with me. But other than that, everything's been posted. And I think a lot of the reasons why it's been successful is because I'm a little bit careful about also what I buy. So if I know that there is absolutely zero information about it available, I tend to not buy something that has no information at all. Or if it's really cheap, okay, I'll buy it. But I'm not going to spend $3,000 buying something that has zero information available, because that is just a recipe for disaster. And if something breaks and it's completely custom, even if you're the most brilliant engineer in the world, you're still not going to be able to fix it unless you have the replacement component. You're not going to make one from scratch. So that would be my advice. Research something before you buy it, so make sure that at least you have a chance of fixing it. Have you ever hidden any Easter eggs in your ASICs or small chips you've made? Yes, I've done it several times. I've put my name on corner of the chips in a different language. I draw on little alien characters and shapes in some of my designs when I was in university. A lot of times I don't do it simply because you're working on a chip fabrication until the last minute. A lot of times in a couple of days you get maybe an hour of sleep just to submit it, and then by then you're just so exhausted and I don't have time to put the nice graphics on the chip. But it's a fun thing to do. I think a lot of ASIC engineers do that, and if I find some pictures, I'll post them for you. And then what kind of degree does your cat have? Well, he also has a Ph.D. in feline existentialism. He's working on his thesis. Once he's done, I'll post it online. And then what do you recommend on getting a VNA at home for use? Yeah, if you can afford a VNA, and even if it's an old one, even if it's a crappy one, I recommend it. VNAs, to a lot of people who've never used them, network analyzers, they seem like this mysterious weird instrument that nobody understands, but it's actually not that complicated once you understand the principle of operation. So read about that. And even if it's a really old one, actually the old ones are good to take apart because you can see all the components and where they are. I did in fact do a video, a teardown of that Anritsu network analyzer, and I talked about how it works, and you can see all the components because they're all microwave components. They're just big bulky things. You can identify them really easily. So if you can get one, get one. I got rid of that Anritsu one because it's just an enormous instrument and I'm looking for a small network analyzer. So maybe if I get one, hopefully maybe somebody will send me one, and then we'll do a review and play around with that as well. And do you own all the equipment that is in your lab and so on? Yes, so this is all my own lab. None of it is from my work. The stuff that I do on the signal path is strictly, completely separate from my work at Bell Labs for obvious reasons. So the kind of research, the kind of work that I do at Bell Labs is very, very separate. In fact, sometimes some manufacturers of instruments come and say, hey, can you do a video on this? And it's this high-end equipment, and they want me to demonstrate something that's close to what I'm working on, and I can't obviously do that. So there is a very clear separation between my work and what is on the signal. But I would love to work and talk about what I do at work as well. And if I have publications and so on, that's where I talk about it, but I can't talk about it other than that, unfortunately. Do you have any advice on picking up equipment from so on and on? eBay, I just talked about that. Yes, so search on eBay, make sure you have information about it before you buy it. And don't go spend a crazy amount of money right off the bat if you've never repaired something, because it's going to be difficult. Start with something simple. Believe me, there are people, and I've seen videos of people who do incredible work with very simple equipment. Having a fancy, expensive equipment does not mean necessarily that you're going to do an amazing job at it. So, or make something incredible no one's ever built before. So even basic equipment, and if you look at my early videos, I had only power supply and oscilloscope, something very simple, very basic. Now you can buy an oscilloscope for $300. So, and I know that $300 is not a little amount of money, and for a lot of people that's still a lot of money, but you can buy an analog one and still learn quite a bit. I know it's not as easy, but trust me, there's a lot you can get done. So don't get discouraged. And I really believe in that line from Pixar's Ratatouille, where at the end the guy says, not everyone can be great, but greatness can come from anywhere. And that, I think, goes at the heart of what I'm trying to say. So lab tour, yes, when the lab is set up, I would be happy to do a lab tour. Were your grades good? Well, I mean, they were good, they were okay, I guess, but I don't think that matters, again, that much. Unfortunately, it matters, both matters and doesn't matter, because at a first impression, on average, if your grades are good, probably are good. But there are a lot of people whose grades are not very good and are exceptional engineers. Again, goes back to what I just said before. So yeah, focus on your grades. Fortunately or unfortunately, it is important. Don't neglect them. Try to do your best on them. I think in the long run, it will probably pay off. Not that if you don't have good grades, you can't do amazing things. And then there's a couple of personal questions. Is interesting. So what's your favorite movie? That's difficult to answer. There are so many. The last one that I saw that had a big impact on me was Ex Machina. And if you haven't seen it, I highly, highly recommend it. It's about artificial intelligence. And it had such a big impact on me. When I came home, I have Alexa and so on all around the house. And I was talking to her, asking her questions, and it was just amazing to see. We were very, very close, very, very close to being at that point. And I think it's such an exciting time to be alive, to see what happens, and if we can really trigger this AI to be indistinguishable from another human being. I also play a lot of video games, actually. And if you haven't played The Last of Us, highly recommend it. Just play the game called Inside. Highly recommended. Great concept, great games. Anyway, I prefer sometimes playing games with stories rather than watching TV. Actually, sometimes I don't turn on my TV for months at a time. And then, how long have you used MATLAB? I've used it since I was an undergrad. It's obviously a industry standard platform for computation. It has many tools and many capabilities. A lot of really amazing stuff. It can do a lot of RF computation as well. Actually, there's RF toolboxes, there's communication toolboxes, image processing toolboxes. And a long time ago, I wrote a MATLAB script with a friend of mine to play online poker automatically for us. So he would move the mouse and detect what cards were on the table. It was really fun. I recommend learning it. There's a lot of also free alternatives to MATLAB, which are based kind of similar on MATLAB's interface. You can check that out as well. And then Oh yeah, somebody asks, I have a bachelor degree and I'm doing my master's. Should I do a PhD? I'm not really interested in research. I don't really enjoy it. If you don't enjoy research, then doing 4 years or 5 years of PhD might take a toll on you. It might be difficult because it's all about research. If you don't want to do that, then with a master's degree, you can still get into a technical field and eventually get into a management position. It sounds to me like that's what you ultimately want to do. You want to be in like a technical management position, more on the maybe closer to the business side than the engineering side, which is totally fine, not a problem, and you can get a job doing that very easily if you're good at it. You don't have to do a PhD, but if you're going to do a PhD and dedicate 4 years of your life to it, make sure you really enjoy doing research, because that's all that is about. And then one last question. I have no idea how long we've been recording, by the way, and last question here I have is, who are you going to vote for? Well, I can't vote because I'm a Canadian citizen, not an American citizen. So I can't even vote here in this country. I'm just lucky that I'm able to be here and work here and so on. And I definitely enjoy being in this country. And this is not a political channel, right? So if you want political information, you can go and find political information in many other places. So I'm not going to talk about candidate versus candidate. That's not the point. But I'll give you my general overview. What do you expect from a nation, right? What do you expect from a country? Sam Harris once said that no nation has ever suffered because its people became too reasonable or too rational or too demanding of evidence. And you want a country, that has equality, that has a respectable level of wealth distribution, not so skewed in insane levels that are in this country, for example. You want to have no racism, no sexism. You don't want to have any of those, right? You want a healthy society. And all of that is true. And I think all of those are a byproduct of something much more fundamental. And that fundamental thing is education, right? With education, you are taught the necessary tools. You're given rational thinking. You're taught about other people. You're taught about what it means to be in other people's shoes. Aside from technical information, you learn a great deal of morality from education. So you want that, right? You want that to be the fundamental thing in your society. If you have enough of that, then it will manifest itself in solving a lot of other problems at the same time. And that's, again, why I do this website in the first place. That's why I value education so highly. Bill Nye was also once asked, how would you solve the problems in the Middle East, right? How would you fix it? I mean, I am originally from the Middle East, and he said something that I think is so insightful and so simple. He said, in order to solve the problems in the Middle East, in the long run, not immediately, is you have to empower and educate the women in the Middle East. Because as soon as you do that, you free them from this compulsory role of reproduction with children whom they have no part of their future. They cannot help. They fall into the same cycle. So the education of women and giving them freedom and allowing them to be independent in those countries will solve a lot of that country's problems over a generation or two. I think that's really insightful. When was the last time you heard people talk about that in such a simple way? Obviously, there's a lot of complicated things happening. You can never solve anything with just one solution, but it will go a very, very long way. So I would say that from your country, for those of you who are American, what you would want a free education system. You would want to have free healthcare for everybody. You would want to have a justice system and a punishment system that's not private, that's not for profit, right? Because that's a conflict of interest. And you want a reasonable wealth distribution along the nation, right? You want to have, obviously, you're going to have people who accomplish something and become very wealthy, and people who don't do anything and aren't going to be wealthy. But there has to be some balance, right? A moral balance in between. Now, none of those are really true in this country, right? But still, it's an amazing place, and it has huge opportunities, and that's why I'm here in the first place. And what I'm trying to do is give back as a response to having the opportunity and the luxury of being here, is to give back to the community, from everybody to all around the world, no matter where you are and who you are. That's the whole point of the channel. Anyway, so that's as far as political as I'm going to get on this, because this is not the right medium for it. And anyway, there's all the questions that I had. So far there's a bunch more. I'm going to try to do them in another episode. And if you like this, and I hope that you enjoy my talking, and it was all shot in one go, so I hope that you liked it. I'm curious to hear back what you thought about the Q&A, and if this is something that you'd like me to do again in the future. And if you like it, check out the Patreon website. I'll put a link right under the video, and let me know. I'll see you next time.